Hi students, how are you? So in the today's class we are going to study about two data structures, stacks and queues. So in the last class we just talked about the data structure in general. We talked about different data structures uh, and we understood that each one has its own importance and they have different applications in different scenario. And today we are going to study about stacks and queues. So talking about stack first. So a stack is quite similar to a stack of any object, like stack of books, stack of dirty dinner plates kept upon each other. So the operations which stack allows are pushing a data packet into the data structure or popping an element out from the stack, etc. Implementations we will talk afterwards. Okay, so coming back to the operations, so as I mentioned, we can insert a data packet into the data structure, or we can remove it from the stack. But the basic restriction is that these insertions and deletions operation, they can be performed only at the top of the stack. So let us try to understand by taking example of a pile of books. Suppose consider this figure as a side view of the pile of books kept on the table. So if you want to add another book into the pile, you can put it only at the top of the pile. So this is similar to pushing operation with stack. And also if you want to take out a book from the pile, the book which you can get out from the pile is the one which is at the top of the stack or top of the pile. So this is similar to the pop operation. So in this, so this is the restriction. You can never, you will never be able to have a direct access to the any books in the middle, right? So as I mentioned above, uh, another operation which stack allows is top, which is examines the most recently inserted element. That is the element which is at the top of the stack. It gives the information about that element. Fine. So stacks are known as LIFO. They are like, that is last in first out data structures. So it is because the data packet which has been added most recently into the stack is the is only available to be for the popping operation. So like as I explained in the example of pile of books, the book which is available at the top is comes out, so that book comes out when we perform the pop operation, but this book is also the latest or most recently added into the stack. That's why it is also based known as last in first out. So last entered book comes out at the first when you perform the pop operation. So here's a pictorial view. There you can have empty stack, and then we pushed an element A into the stack. So the top is updated to A. Then we pushed another element, say B. So top is shifted to B. Then finally we removed another element B from the data structure. So by popping operation, so then the top is again updated to A, and there's only one element left in the data structure. So now we understand queues. Try to understand queues. The queues are very similar to what we often found. Let's say queue of customers waiting in front of ticket windows to get the ticket. And the basic operations performed on the queue data structure are enqueuing, which is very similar to inserting a data element, and dequeuing, which is what we call as pop function in the stack data structure, right? So in the queue data structure, as I said, it is also like like stack, it is also list. However, in the queue, insertion operation is done at one end, while deletion is performed at the other end. So in the stack, what happened was both in pushing the element and popping the element took place at the same end, that is at top of the stack. But in the queue, the queue, suppose this is the data structure, then enqueuing is done from one end. So pushing the elements, pushing the data packets into this data structure is done at one end. While if you want to remove any packet from the data structure, then this has to be removed from this end. So the basic reason, now, this restriction of having two ends for the two operations separates it from stack. So that's why the element which was inserted at the very earliest is the first one to get removed when we perform the dequeue operation, right? And the element which is inserted latest into the data structure is removed at the is removed at the last if we perform the dequeue operation. So that is why it is also known as first in first out. That is, a data packet which is inserted at the earliest is the first one to be removed. Making sense? Fine. So yeah, so here you can see that this is the data structure. If you are performing inserting operation here, we can remove the element from here, quite similar to the last slide, right? Okay, so these are what about stacks and queues. Is the basic difference between stacks and queues, that stack is based on last in first out principle, whereas the queue is based on first in first out principle, in which the first element which was entered that was entered into the queue's data structure is removed at the very first when we perform when we perform the popping operation or dequeuing operation. So in the next class we would be understanding the implementation of these two data structures. So if you have doubt in of these data structures, any of these concepts, then please raise your hand. Thanks for listening. Thank you.